this lesson, we're going to discuss simple interest, compound interest, and annuity. At the end of this lesson, you are expected to demonstrate the following: compute a simple interest, compute a compound interest, compute the effective rate, and compute an ordinary annuity. In engineering economics, economy consists of a variety of methods that compare two or more alternatives and then select the best alternative from among these options. Engineers would try to find solutions to some of these problems and evaluate the various economic effects that may result from the implementation of an engineering project. This lesson will tackle the following topics: simple compound interest, ordinary annuity, financial mathematics, and comparison of alternatives. Let's start with the simple interest. In financial transactions, interest is an amount paid by a borrower to a lender or investor for the use of money over a period of time. Interest that is paid as a percent of the amount borrowed or invested is called simple interest. This is the formula for simple interest. We have I is equal to PRT. I is the interest earned or owed. P is the principal invested or borrowed. R is the interest rate per year. And T is the number of years. If the number of days used is 360 in computing for T, which is less than 1 year, then the interest is called ordinary simple interest. If it uses 365 days in 1 year or 366 days for a leap year, then the interest is called exact simple interest. The total amount paid, which includes the interest, is called the future value or the maturity value. So this amount is obtained by the following formula. So we know that the future value is equal to the present value or the principal plus the total interest earned. And since your I is is P plus RT, then we can have F is equal to P times the quantity 1 plus RT. So let's have an example. A person borrows 28,000 at 8% simple interest per year. So find the accumulated amount of debt in 120 days, assuming an ordinary interest year. So we'll take this as your capital or the principal or the present value. This will be our R, which should be in the decimal form. So 8% is 0.08. Okay. So we want to find F, which is equal to P times 1 plus RT. So 28,000 is your P plus 0.08 is the interest. And then the number of years, we have 120 number of days. Now, since this is ordinary interest here, so divide by 360. And we get the value of F, which is 28,746.7. If you want to find the total interest earned, that is just the difference between the future value 28,746.7 minus the principal value 28,000. So the total interest is 746.7. Okay, so let's have another example. So at what rate of simple interest will earn 150,000 to accumulate to 213,000 in 3.5 years? Okay, so again, we use the formula F is equal to P times 1 plus RT. Now, 213 is your F, and your P is 150,000. So, 1 plus R, and then we have 3.5 years. Okay, so solving for R here will give you 0.12 in decimal form, or in percentage form, that is 12%. The compound interest is computed based on the principal amount and the total accumulated interest earned. So the total accumulated amount on the principal P for n periods at an interest rate of I per period is given by this formula. F is equal to P 1 plus I raised to N, where N is the total number of periods. So if P denotes the number of years, and then M is the compounding period, okay, then N is equal to M multiplied by T. And then the interest per period will be the nominal rate J divided by M. So the interest rate J is called the nominal rate, and M is the number of compounding periods in a year. For example, a mother invested 100,000 in a mutual fund on the date her first son was born. If money is worth 10% compounded semi-annually, what is the amount the son will receive on his 18th birthday? Okay, so let us draw the cash flow diagram. So 100,000 is invested. So this is a present value, and then that will be withdrawn after 18 years. So that is a future value, which is what we want to know. This is after 10 years, rather 8 on the 18th year. So this is a present value, and then the rate is 10% compounded semi-annually. So we have 2 here. The formula for, so this is a compound interest. So the compound interest formula is F is equal to P 1 plus I raised to N, where I is equal to J. Take note that I is the interest rate compounded annually. Now, since we have 10% is a nominal rate, so this will be 0.1 divided by the number of compounding periods. So this is semi-annually, so twice in a year. So this will be 0.05. And then the total number of periods in 18 years will be, so this is m times t, we have 2 times 18, so that will be 36. So we have f is equal to 100,000. Okay, 1 plus 0.05 raised to 36. So this is 579,182. Okay, let's have another one. How long will it take to triple the sum of money invested at 12% compounded monthly? So again, we have f is equal to b 1 plus I raised to n. Now, triple the sum of money, so this is 3 times p. And then we have 0.12 here. This is J, compounded monthly, so M is 12. And then raised to N. Okay, so this will cancel out. We take the loan of both sides. So this will give you N times loan of 1 plus 0.12 over 12. And then solving for n here will give you $110.41. So divide by 12, this is monthly, will give you 9.2 years. So n is equal to, or rather t is equal to n divided by m, to give you 9.2 years. Okay, what is an effective rate? So effective rate is equivalent to interest rate compounded annually. So that is the rate per year. We can use this to compare two rates, no, with different nominal periods. And the formula is 1 plus j over m raised to m minus 1. For continuous rate, so that is almost equal to compounded daily, that can be reduced into exponential. Okay, W is, or rather the effective rate, this is the effective rate, is e raised to j minus 1. And then, if two nominal rates are equivalent, then they have the same effective rates. So, this is W1, the effective rate for J1, and then this is the effective rate for J2. Okay, so let's have an example. Find the annual yield equivalent to 12% interest compounded every 3 months. So the effective rate is equal to 1 plus j over m raised to m minus 1. So this is 12% compounded every 3 months. So in a year that would be 4 compounded quarterly. So raised to 4 minus 1. And the rate will be in decimal form. This is 0.1255 or 12.55%. For letter B, 11.8% interest compounded continuously. So W is equal to E raised to J minus 1 to E raised to 0.118 K minus 1. So this is 12 point, or rather 0.1252, or that is 12.52%. Now let's talk about annuity. An annuity is a series of equal payments made at regular intervals of time. It is also known as a sinking fund, which are used to or for future financial obligations such as educational expenses for children, replacement of a machine or equipment, and amortization of loans or assets. Ordinary annuity is one whose payments are made at the end of each interest period. The present value P and the future value F of an ordinary annuity A are given by the following formulas. So this is the formula for the present value. So A here is the ordinary annuity. And then this is your future value. And from the previous, I is also the interest rate per period, and N is the total number of periods. If the annuity involves, or the annuity problems involve inflation rate, then we can treat the inflation rate as an interest rate. And we know that inflation is an economic condition during which there are increases in the cost of goods and services, which may be expressed in percentage form. So when we speak of an annual, or we can speak of an annual inflation rate of, let's say, 5%. So we can treat this as an interest rate per year. For example, a chemical engineer borrowed 150,000 at 9% interest rate, compounded semi-annually, and paid 20,000 per year for the last 4 years. So what would be the final payment at the end of the 5th year? So let us construct our cash flow diagram. So 150,000 is a future value. So at year 0, so we have 150,000 here. Since it is borrowed in the, we'll take the point of view of the borrower. So we'll take this as a positive value at year 0. So this should be upward. And then let's say this is the last payment on the 5th year, and then there would be 1, 2, 3, 4 annuities here. which is 20K each. The interest is 9%, so that will be 0.09. That is, wait, this is compounded semi-annually, so this will take this as our J, and then the compounding period will be 2. This is what we want to know. Now, since 150,000 is a present value, so we compute for the present value of this annuity, for annuities. And then the future, the present value of K. So we have 150,000 here, which is equal to the present worth of this annuity and then the present worth of this K. So that will be the present worth of an annuity is equal to A over I multiplied by 1 minus 1 plus I raised to negative n. So this is 20,000 okay, over your I is J over M, and then N is MT. So this will be 0.09 divided by 2. Okay. And then 1 minus 1 plus 0.09 divided by 2. Now we have 4 annuities here, so 4 times 2, so the total period will be 8 plus the future, the present value of K. So using the formula, if F is equal to P 1 plus I raised to N, then the present value will be F times 1 plus I raised to negative N. So I have here 1 plus 0.09 over 2. Okay, we have 5 years here, so times 2 will give you 10. And then we compute for the value of K here should be 28,081. So this will give you, this first time will give you 131,918. This coefficient would be 0.643928. Okay. So this will be the final payment on the 5th year. So let us continue. An equipment costs 200,000 today and has a resale value of 50,000 after 10 years. The inflation rate is 5% per year. The annual interest rate earned on the investment is 6%. So how much money needs to be set aside each year in order to replace the said equipment with an identical model of 10 years from now? So we try to draw first the cash flow diagram. So this is your 200,000. This is a present value, and then the resale value is 50,000. That is at the end of the life or on the 10th year. So we have 6% here, and then the inflation rate is 5%. Okay, now we compute for the future value, okay, of 200,000 using the inflation rate. So this is the actual amount of 200,000 after 10 years, no, with an inflation rate of 5%. So that will be 200 plus 0.05 raised to 10 years, and this gives you 325,779. So this will now be the cost of this equipment 10 years from now, no, with an inflation rate of 5% per year. But take note that after 10 years, the old equipment can be sold by 50,000. So the amount needed to be raised will be 325,779 minus 50,000. So this is 275,779, and we compute for the annuity. So this is the amount needs to be set aside each year, no? So this is an annuity. So this will be a future value 275,779, which is equal to A over I, which is 0.06, okay, multiplied by, so 1 plus I, so 1.06. Okay, this is raised to 10 years. And then minus 1. Okay, so A should be 20,000 923.8. Okay, so this should be your final answer.